What if the most decisive strike in a modern war doesn't destroy missiles but makes them useless? In the opening hours of this operation, something far more consequential than a conventional airstrike took place. This wasn't just about hitting targets, it was about dismantling the invisible system that makes a modern military function. And once that system collapses, everything built on top of it begins to fail. At the center of this shift was a single facility, one that didn't produce rockets, fuel, or warheads, but something far more critical: the intelligence and electronics that guide them. When that facility was hit, the impact wasn't immediately visible across the battlefield. But within days, the consequences began to surface in ways that fundamentally changed the balance of power. The strike itself was precise, coordinated, and deeply integrated across multiple domains. Israeli aircraft, supported by U.S. intelligence and operational planning, penetrated heavily defended airspace and targeted a key node inside Tehran. This wasn't a broad bombardment. It was a calculated effort to erase a specific capability, one that sits at the core of modern missile warfare. The target was Iran Electronics Industries, a central hub responsible for the systems that allow missiles and drones to think, adapt, and strike with precision. These systems include inertial navigation units, guidance modules, optical targeting kits, and electronic warfare components. Without them, a missile is no longer a precision weapon. It becomes a blunt instrument. And that distinction changes everything, because modern warfare is no longer defined by how many weapons you have, but by how accurately and effectively you can use them. When the electronics that guide those weapons are destroyed, the entire system begins to collapse from within. The strike wasn't designed to penetrate deep underground or destroy hardened bunkers. Instead, it focused on internal destruction, fires, heat, and contamination. In facilities operating at nanometer precision, even minor environmental disruption can render entire production lines useless. Smoke alone can destroy calibration processes. Heat can corrupt sensitive components. Data loss can erase years of research. What followed was not immediate silence, but gradual degradation. Iran's underground missile complexes, long considered one of its strongest strategic advantages, remained physically intact. Buried deep beneath mountains, protected by layers of rock far beyond the reach of conventional bunker-busting weapons, these sites were designed to survive exactly this kind of attack. But survival is not the same as functionality. Missiles stored in these facilities require constant maintenance, calibration, and software updates. Their guidance systems degrade over time. Their components require replacement. Without a functioning supply chain for electronics, these missiles slowly lose their effectiveness, even if they remain untouched. In other words, the infrastructure survived. The capability did not. This is where the strategy becomes clear. Instead of attempting to destroy what is hardest to reach, the operation targeted what is hardest to replace. Electronics manufacturing, especially at high precision, cannot be quickly rebuilt, especially under sanctions, limited access to materials, and ongoing conflict. And the effects didn't stop there. At the same time, follow-on strikes targeted tunnel entrances, ventilation shafts, and launch access points. Not to destroy the missiles inside, but to restrict their use. Bombers collapsed entryways, trapping mobile launchers underground. Surveillance aircraft maintained constant watch, striking any system that attempted to deploy. The result was a layered approach: disable the brain, isolate the body, and monitor any attempt at recovery. Within days, missile launch activity dropped dramatically, not because the weapons were gone, but because the system that enabled coordinated, precise strikes had been disrupted. This marks a fundamental shift in how military power is applied. For decades, Iran's doctrine relied on two key principles: concealment and precision. Missiles hidden underground, paired with advanced guidance systems, created a credible deterrent. But when one of those pillars is removed, the entire structure becomes unstable. What remains is a less predictable, less effective capability, one that relies on volume rather than accuracy. And in modern conflict, that's a significant downgrade. The broader implications extend far beyond a single battlefield. Iran's network of allied groups across the region has long depended on centralized support for advanced systems, guidance kits, drone technology, and electronic components. When that central hub is disrupted, the ripple effects spread outward. Suddenly, systems that once operated with coordination and precision begin to lose that edge. Drones still fly, but with reduced effectiveness. Missiles still launch, but with less accuracy. Operations continue, but with diminishing returns. This is how modern conflicts evolve, not always through large-scale destruction, but through targeted disruption of critical systems. And rebuilding those systems is far from simple. High-precision electronics manufacturing requires specialized environments, advanced equipment, and highly trained personnel. It depends on global supply chains, access to semiconductors, and years of accumulated expertise. Under sanctions and active conflict, rebuilding that capability becomes a long-term challenge, not a short-term fix. Even potential external support faces limitations. Global supply chains are strained, and geopolitical constraints limit the transfer of advanced technology. What was once a centralized, efficient system becomes fragmented and uncertain. And that uncertainty changes strategic calculations. Because deterrence is not just about having weapons, it's about the confidence that those weapons will work as intended. When that confidence is reduced, so is the effectiveness of the deterrent. What we are seeing here is not just a tactical success, but a strategic shift. A demonstration that modern warfare increasingly targets systems over structures. Capability over quantity and precision over scale. The missiles may still be there. The tunnels may still exist. But without the systems that bring them to life, their role in the conflict has fundamentally changed. And that raises a larger question, one that extends beyond this operation. If the future of warfare is defined by targeting the brain instead of the body, then how many other military systems around the world are more vulnerable than they appear? Because the next conflict may not be decided by who has more weapons, but by who can render the other side's weapons ineffective before they're ever used. If you want more deep, no-nonsense military analysis like this, make sure to subscribe to the channel and stay ahead of the story.